Hello everyone. Today I am going to walk you through a low level yet fascinating topic: how to build a custom dynamic array in Swift using UnsafeMutablePointer. This is based on an article I wrote recently, and the goal is to explore what goes on under the hood when we work with Swift arrays. So, why build our own array when Swift already gives us a powerful array? The idea here is to get hands-on with Swift's memory model, to really understand how memory allocation, resizing, and pointer manipulation work at a low level. This project also gives us a chance to implement useful protocol conformance like sequence and debug output. The custom array we are building has a few key features. First, it grows dynamically just like Swift arrays. Second, it uses unsafe mutable pointer to handle memory manually, so we can see how allocation and resizing are managed. And finally, it conforms to the sequence and custom debug string convertible protocols to support iteration and pretty printing. At the core, we have few important properties. Capacity. This keeps track of how many elements we can store. Then we have size, tracks how many we are currently storing. Storage is the raw memory buffer, and then we have some computer properties like count and is empty for convenience. See this code, this is initializer. When you create new array, it defaults to a capacity of 2. We allocate that many slots in memory using unsafe mutable pointer allocate method. At this point, no values are stored yet. We are just preparing the buffer. Now look, now let's look at how resizing works. If we reach the limit of current capacity, we double it. We allocate a new buffer, copy the elements over, deallocate the old one, and update our pointers. This is very similar to what Swift array do internally, but here we are controlling every step ourselves. Next is appending, which is straightforward. We first make sure there is enough space using resize. Then we place the new element in the next free slot and increment the size. It's minimal but effective. Inserting at a given index is a bit more involved. We validate the index, resize if needed, and then shift elements to the right using a reverse loop to make room for the new value. It is an excellent example how memory layout matters in low level structures. See the code. To make our array usable in for loops, we implement the sequence protocol by returning a simple iterator. For debug output, we convert our pointer based array into a regular Swift array in debug description. This makes our type more user friendly during development. Using unsafe mutable pointer means Swift's usual memory safety guarantees are off. We are responsible for allocation and deallocation, and we must avoid leaks. dangling pointers, or overwriting memory. It is powerful, but we need to be very careful and always deallocate memory when done. There is a lot more we could add, removing elements, subscripts for random access, trimming unused capacity, or conforming to collection. We could also benchmark this against SIF's native array to understand performance trade-offs. If you are interested in digging deeper, I recommend exploring Apple's documentation on UnsafeMutablePointer, checking out WWDC videos on memory management, and reading about how the Swift standard library handles collection types under the hood. To wrap up, this project is a fun and educational deep dive into Swift's memory model. It shows how we can use raw pointers responsibly to build dynamic data structures, and it opens door to understanding and even contributing to Swift standard library concepts. Thanks for watching. To read the full article, just visit this URL. If you found this helpful, share it with your team and subscribe for more mobile tech insights. Thank you.